Hello children, today we are going to learn about prime numbers and composite numbers. In the previous video on factors, you learnt that a factor is a divisor that divides the given number exactly. You already know that all natural numbers are divisible by 1 and itself, which means that all natural numbers have at least two factors, that is 1 and the number itself. For example, 2 will have the factors 1 and 2, 3 will have the factors 1 and 3, 4 will have the factors 1 and 4, and so on, apart from other factors. Did you notice that in the example, I started from the number 2 and not 1. Do you know why? The reason is all natural numbers have at least two factors except 1. 1 has only one factor, and that factor is 1 itself. 1 is the smallest and the greatest factor of the number 1. And since 1 is the only natural number that has only one factor, it is called a unique number. We know that all natural numbers have at least two factors, but that does not mean that numbers will have only two factors. They can have two or more than two factors. Based on this number of factors that they have, natural numbers, except 1, are classified into two groups. Numbers that have only two factors, that is 1 and the number itself, which are called prime numbers, and numbers that have more than two factors, which are called composite numbers. Now we know that numbers that have only two factors are called prime numbers, and numbers that have more than two factors are called composite numbers. Using this definition, let us now find out the prime and composite numbers between 1 to 10. 1, now we know, is neither a prime number nor a composite number. It is a unique number. The factors of 2 are 1 and 2, so that makes it a prime number. 3 also has only two factors, 1 and 3. 3 is also a prime number. The factors of 4 are 1, 2 and 4. That is more than two factors. 4 is a composite number. 5 is equal to 1 into 5, so it has only two factors. 5 is a prime number. 6 has 1, 2, 3 and 6 as its factors. So that makes 6 a composite number. 7 has only two factors, 1 and 7. 7 is a prime number. 8 has four factors, 1, 2, 4 and 8. 8 is a composite number. The factors of 9 are 1, 3 and 9, which is more than two factors. So 9 is also a composite number. And the factors of 10 are 1, 2, 5 and 10. 10 is also a composite number. Now we know that the prime numbers between 1 to 10 are 2, 3, 5 and 7. And the composite numbers between 1 to 10 are 4, 6, 8, 9 and 10. Classifying the prime and composite numbers between 1 to 10 by listing the number of factors that each number has was easy because it was a set of only 10 numbers. Using the same method to find the prime numbers between 1 to 100 will not be that easy. So, instead of listing the number of factors, we will use a method called the Eratosthenes sieve method. In this method, we will write the numbers 1 to 100 in a table, then cross out all the composite numbers one by one till only the prime numbers remain in the table. We'll now use the Eratosthenes sieve to find the prime numbers between 1 and 100 for which we'll first write the numbers 1 to 100 in a table. We already know that 1 is not a prime number, so we'll cross out 1. The next number is 2, which we already know is a prime number. But all the multiples of 2 will be composite numbers because along with 1 and the number itself, the multiples of 2 will have 2 also as a factor. Since all multiples of 2 are composite numbers, we will cross out these multiples from the table. The number after 2 is 3, which we know is a prime number. And like the multiples of 2, all the multiples of 3 will be composite numbers because along with 1 and the number itself, they will have 3 as one of its factors. Few multiples of 3 have already been crossed out because they are multiples of 2 also. Now we will cross out the remaining multiples of 3. The next number 4 is a composite number, and as we can see in the table, all the multiples of 4 are also composite numbers. After 4, the number 5 is a prime number, but all the multiples of 5 will be composite numbers, some of which have already been crossed out because they are multiples of 2, 3 or 4. Now we will cross out the remaining multiples of 5. After 5, the number 6 and all the multiples of 6 are composite numbers, and as you can see, they have already been crossed out. The next number 7 is a prime number, but the multiples of 7 will be composite numbers. So we'll cross out the multiples of 7, some of which have already been crossed out because they are multiples of other numbers as well. After 7, the number 8 and all the multiples of 8 are composite numbers, and you can see that they have already been crossed out. Similarly, the number 9 and all the multiples of 9 are composite numbers, and 10 and all the multiples of 10 are composite numbers. Finally, we have crossed out all the composite numbers between 1 to 100, and we are left with only the prime numbers in the table. You can see that there are 25 prime numbers between 1 and 100, and they are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. Now that you know the 25 prime numbers between 1 and 100, let us look at some interesting facts about prime and composite numbers. As you can see in the table, 2 is the smallest prime number, and 2 is the only even number that is prime. This means that all the prime numbers except 2 are odd numbers. You can also see that 4 is the smallest composite number. Now look at the numbers 2 and 3. They are two prime numbers that come one after the other, which means they are two prime numbers that are consecutive. Apart from 2 and 3, none of the other prime numbers are consecutive, which means we can say that 2 and 3 are the only consecutive prime numbers. Next, look at the prime numbers 3 and 5. They are two prime numbers that have one composite number in between them, or they are two prime numbers that have a difference of 2 between them. Such numbers are called twin prime numbers. Hence, we can say that A pair of prime numbers that have a difference of 2 between them are called twin prime numbers or just twin primes. Apart from 3 and 5, other pairs of twin prime numbers are 5 and 7, 11 and 13, 17 and 19, 29 and 31, 41 and 43, 59 and 61, 71 and 73. You can see that there are 8 pairs of twin prime numbers between 1 and 100. A quick recapitulation before we end. All natural numbers except 1 are either prime or composite numbers. Numbers that have only 2 factors are called prime numbers. Numbers that have more than 2 factors are called composite numbers. 1 is neither a prime number nor a composite number because it has only one factor. Hence, it is called a unique number.